Hello and welcome to another press briefing with Covering Climate Now. I'm Mark Hertsgaard. I'm the Executive Director and co-founder of Covering Climate Now and also the Environment Correspondent for The Nation magazine. Our subject today, climate attribution science. And I'm proud to add that this press briefing is jointly co-sponsored along with Covering Climate Now by Climate Central and World Weather Attribution. For those who don't know, Covering Climate Now is a global collaboration of more than 500 news outlets that reach a total audience of billions of people. We're organized by journalists for journalists to help all of us do better coverage of the defining story of our time. You can go to our website, coveringclimatenow.org, to see a list of our partners, apply to join us, sign up for our weekly newsletters and all of our resources, all of which are free of charge. So to today's session, another way to frame the topic rather, is the title we chose for this session, which is how do we know that climate change fueled that storm? Not just Hurricane Helene, but all the other extreme weather hitting us now. Well, you're about to find out. But first, as images of Helene's destruction continue to pour in from North Carolina, let's all bear in mind that extreme weather is a global phenomenon. Powerful flooding is striking Nepal right now. A typhoon is threatening the Philippines. A few weeks ago, there was deadly flooding in Thailand, in Eastern Africa, in Eastern Europe. Before that, ferocious wildfires in Greece, Portugal, and California. It is extremely important that we as journalists understand and convey to our audiences the role that climate change plays in these disasters. To read or watch much of the media coverage of these disasters, the average person would think that climate change played no role because few stories have even mentioned the term climate change. There used to be a reasonable explanation for that because until recently, the rule of thumb was, and we even heard this from scientists, you can't attribute any single weather event to climate change. But that rule of thumb is something we must now leave behind. It is no longer scientifically accurate. And that's because of a discipline known as climate attribution science that we're going to be talking about today. Now scientists can provide pretty specific calculations of just how much more likely climate change has made a given extreme event. And this is really critical for us as journalists. They can do that fairly quickly, often when those extreme events are still in the news. So for example, scientists at Climate Central announced last Thursday, before Hurricane Helene made landfall in Florida, before that, they announced that the overheated water in the Gulf of Mexico that was amping Helene up into a Category 4 storm was made 300 to 500 times more likely by global warming. 300 to 500 times. That's the kind of number that can land with audiences. And yet, with few exceptions, most news coverage of Hurricane Helene has failed to mention that critical fact. Although I want to give a shout out here to our colleague at NBC News, Chase Kane, whose story did do a fine job of reporting this, and you should be able to see that in the chat shortly. So as journalists, we've got to do better than this. Yes, our coverage of disasters should continue to prioritize immediate life-saving information, how to evacuate, where to find emergency assistance, and so forth. But we also need to help our audiences understand why this is happening to them. These are not natural disasters. They are fueled by climate change. To talk us through all that, CC Now is proud to host literally two of the world's top experts on climate attribution science and how to communicate that science to the public. They'll be presenting their findings over the next 20 minutes. Full disclosure here, they do not yet have their full report on Hurricane Helene and the role that climate change played in that. Stay tuned, though, that is coming next week. But what you will get here today is a firm understanding of how climate change attribution science works so that you can carry that into your coverage going forward. And of course, we'll be taking your questions after their presentations. You can go to the Q&A button at the bottom of your screen, submit your questions there. Please give your name and also your news outlet, and I'll forward those questions and read them out for our panelists. And please, these are questions only from working journalists, only working journalists. Now, let me first introduce Dr. Friederike Otto. She is a senior lecturer in climate science at the Grantham Institute of Imperial College in London. Physicist by training, she is the co-founder and lead scientist for World Weather Attribution, an international effort to analyze and communicate the influence of climate change on extreme weather events. And Bernadette Woods-Placky, our close colleague here at Covering Climate Now. She's the chief meteorologist and vice president for engagement at the nonprofit Climate Central. She directs Climate Central's Climate Matters program, where she leads a team that creates weekly data and other reporting resources for media professionals on the links between climate change and weather. My fellow journalists, if you're not already following both of these individuals, you must. It's essential for your coverage. And I hope you'll now please join me in giving them both a warm virtual welcome. And with that, I turn it over to Dr. Otto.
Thank you very much for this introduction. And yeah, let me just quickly share my screen. So I will give a very brief introduction of what we do or what it is when we talk about extreme event attribution. And of course, can go in much more detail in the questions afterwards. So the initiative I lead, World Weather Attribution, is the highlight here is really on the word rapidly attributing extreme events. So we are doing studies on answering the question, what's the role of climate change in this event, in the immediate aftermath of the event. But we are doing the same thing that you would do as a scientist in a peer-reviewed study. So we use methodologies that we have used in peer-reviewed studies many times before. We are just doing it much faster than you normally do in a peer-reviewed study. And of course, because we publish the results before it goes through peer review, we can share them with you within a week or two after the event. But in most cases, we actually submit the studies afterwards to a peer-reviewed journal. And so far, in the over 80 studies we have done, the numbers have never changed in the peer review process. The prose usually improves when you give it a bit more time, but the results have always been the same, which I think is important to highlight. So what we do when we do an attribution study in our team, and I think this is really important, why we actually care about climate change, why we do this work, is not because storms are fascinating, even though they might be for a lot of people, or because we care about global mean temperature per se. Why we care about climate change and why we do these attribution studies is because climate change affects lives and livelihoods of people across the world. And it is people in every country, in every city. It's not just some people somewhere else or sometimes in the future. It is here and now, and it's been the case for many years now, decades, but in the most recent years particularly. And climate change manifests through the increased likelihood and intensity of extreme weather events. And so the event where we can see this most strongly are extreme heat events. So with our team, we have, we work with the Red Cross Climate Center, and every time there is an extreme event with drastic humanitarian consequences, we consider doing a study. We can't do a study every time because there are too many extreme events happening. But over the last 12 months, about 80 extreme heat waves across the world triggered for our team. And we have done 8 studies on heat waves, and you can see here just really as an illustration, an overview of where these happened. And in 6 of these heat waves, we found that without human-induced climate change, so without the burning of fossil fuels, these heat waves would never have happened. So there would have been a heat wave maybe, but it would have been a much cooler heat wave, and so therefore maybe not even been considered as a heat wave and with much fewer consequences. And of course, the 2 other heat waves that would not have been impossible, but still possible, would also have been much more likely with much less likely without human-induced climate change. That's sort of the headlines of our studies. That's sort of the main findings we have. And I would use one of these heat waves that happened earlier this year in parts of the US, Mexico, and other parts of North and Central America, just to illustrate what we do and what that means. So when we have an extreme event, and that is the same thing for all events, the first thing is, how do we characterize this event? And in our work, we always try and base that on the impact. So which aspect of the weather did affect people? Was it just the heat, so just the high temperatures, or was it actually heat and humidity? So if it was a heat wave happening during very humid climates, or was it just daytime temperatures, or were also the nighttime temperatures important? And so based on that, we define an event. And for this heat wave, we actually looked at 5-day maximum temperatures over an area covering Mexico and then parts of the US and Honduras. And we found, and then the next thing that we need to do is, okay, this heat wave that we've just characterized, what kind of event is that in the world we live in today? So in a world that is already 1.3 degrees warmer than it would have been without human-induced climate change. And what do I mean with what kind of event is that? I mean, what are all the possible heat events that could happen in this part of the world, in this climate we live in, at this time of the day? So we look at possible weather, and that gives us then a return time for the event. So in this case, it was a 1 in 15 year event. That doesn't happen, it happens every 15 years, but in any given year, you have a 1 in 15 chance of such an event to occur. And we find that by basically looking at observations, statistical models, and climate models, and that gives you a curve like this red curve on my slide here, of all the possible temperatures over this event, and then the observed event then gives us the likelihood for the event to occur. And then, because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can take these out of climate models' atmospheres and also use statistical models and look at how would this weather look like, what would possible weather look like in a world that was 1.3 degrees cooler. And this, in this case, gives us something like this blue curve. And these two curves are from an event where actually the climate change made the event only possible, and it would have been impossible because the blue curve here actually does not overlap in the extremes in the event we have observed with the red curve. So that means there would probably have been warm temperatures, but it would not have been a heat wave, and it would never have been as hot as it was. For the event in Mexico and parts of the US, we found that it would have been possible, but it would have been a much rarer event without human-induced climate change. And you can see that on the leftmost part of my slide, where you have this one tiny pink dot in the sea of gray dots, and all the gray dots represent possible weather events in a world without climate change, and this one pink one is the one in over 500-year event. So that would be how rare this event would have been without climate change. And this is sort of the key idea behind attribution. We look at possible weather in the world we live in today and compare it to possible weather in the world that might have been without climate change, using all sorts of different climate models and different observations to really get an idea of how sensitive is our results to the exact model and data that we're using. We can also ask the question slightly differently, and this is what is indicated here with these burning embers or burning stacks, however you want to call them. So we can also say, okay, what is today a 1 in 15-year event is actually 35 degrees on average over the maximum temperatures for 5 days. So this is the second, so from the right stack. And in a world without climate change, the 1 in 15-year event would have been a lot cooler. It would have only been just over 33 degrees Celsius. But what you also see here is, of course, a world without climate change seems like a very, very long time ago and something that's barely relevant, but actually a lot of climate change have happened in just this century. And so in this study, we also looked at how much has just the emissions, just the fossil fuels we've burned this century, how much have they made this event more likely and more intense. And this is what you can see here. So just the last 25 years have made this heat wave a whole degree hotter. And that really matters because heat waves are by far the deadliest extreme events that we know. They, of course, have huge impact on people that are already very vulnerable. For example, people living outdoors, homeless people, people in refugee camps, in conflict zones, people already living under water shortages, but also people that are living amongst most of us in our daily lives, construction workers, transport drivers, farmers, or just elderly people living in poorly insulated homes in every city across the world. And heat waves are also deadly, especially if they're combined with power outages and so on, for people who are not often considered vulnerable. So heat waves are really dangerous. And a lot of the heat waves we see today would actually not have happened in a world without climate change. And so really drawing attention to this is important. So this is just really very, very rushed, the key core idea behind attribution and why it matters and for whom. I can't show you the results for the Hurricane Helene yet. I just want to highlight very, very briefly the questions that are really important to consider and that determine also the results of the study. So for a heat wave, it's relatively straightforward how you characterize the event. It's usually temperature. But for a hurricane, there are different aspects. So there's extreme rainfall that leads to flooding that causes a lot of the impacts, but also the high wind speeds are a really important factor. And climate change affects these different aspects quite differently. And so for a typhoon Gemi that hits it didn't hit the Philippines, but it caused a lot of destructions in the Philippines and then hit Taiwan and also mainland China a couple of months ago. We did a study that is in the structure exactly the same what we're currently working on for Helene, and where we will present the results in a week from now. So the first thing is really to see where did it rain and how do we characterize these events. And so in this case, it was 3-day rainfall that you can see here over the Philippines, and then 2-day maximum rainfall over Taiwan and Hunan. And then we also looked at the other components, and Mark has already said that, that of course the sea surface temperatures play a really important role for how powerful a hurricane or a typhoon can become. And then there's something that's called the potential intensity, and that's a combination of the high temperatures of the sea surface and the vertical winds, because if the vertical winds are strong, the hurricane just dies down and doesn't actually get very powerful and reach the coast. But if they are weak and the temperatures, sea surface temperatures are high, that combination can lead to very powerful storms. And so that's also something that we will look at, and that in this case of the Typhoon Gemi, we found that the rainfall was about 40–50% more likely, but the potential intensity had increased dramatically because of human-induced climate change. And that means that there's just the conditions that such typhoons can occur are much, much more frequent than they would have been without human-induced climate change. And so we'll tell you in a week what we can say about Helene. And yeah, I think I'll keep it at this. Here's just a brief summary of what are the important things to communicate. Is first of all that what are the impacts and who is impacted? In this case, heat waves are really deadly. You can actually prevent these deaths if you have heat action plans. There are some good examples, for example, from lots of Indian cities that have implemented them recently, and their death toll really get down. And then what the role of climate change is. And then, of course, really important, the cause of climate change, and that's the burning of fossil fuels. If we don't stop this, that will have everything of these types of events, most of them will get a lot worse. So I'll stop here and hand over to Bernadette.
All right. You going, Mark, or do you want me to jump in?
You go ahead. I'll just quickly note, fellow journalists, Dr. Otto just mentioned these heat plans. that is a really good story to follow up. If you're a local reporter, does your city, does your region have a heat plan? For example, Philadelphia instituted one of these years ago. The Los Angeles Times has done some great reporting on the lack of heat plans and what that has meant in the Los Angeles, California area. So this is an opportunity to do both solutions and accountability reporting with this grounding in the science. So thank you very much, Dr. Otto, and Bernadette, take it away.
Absolutely. So thank you everyone for joining us today. Unfortunately, extreme weather is always such a timely discussion, right? We're talking about Helene, but every week it's something different. Every day it's something different now. And I want to bring you up to speed on this really fascinating scientific branch of climate science, which we've defined as attribution science. Now, weather is the primary way that people experience climate change. And as Freddie really laid out, it's so important because people know something's happening, but still they don't always understand what. And you're in a unique position to make those connections for people. We're going to take you through the science, the numbers, all of that, and that's great to understand. But for the public, sometimes it's simply just making that connection. And I hope that if you get nothing out of today, you get the confidence to make the climate connection in these stories for people. Also, as we talk about rebuilding, which happens right away after so many of these events, we have to know how to rebuild. And that's why the Red Cross Red Crescent has always been a partner of World Weather Attribution, because it's really critical to have solid information as we think about our futures too. So let me take you back real quick here, quick history of 20 years of extreme event attribution science. Because in the 90s, we were starting to understand the general trends in different weather of how climate change was influencing that. But then there was this landmark study on the 2003 heat wave, came out in 2004, and it showed the role of climate change making that event worse. And this was, for all who remember, an absolutely awful event with tens of thousands of people dying. And that really shifted the grounds on how people can look at weather events now. And this methodology was introduced into science. And then by 2011, this report was put together by the Bulletin of the American Meteorological Society. It was a summary of a lot of attribution studies that were starting to come out because it was coming up in the literature. So enough so that there was a special report put out by the AMS. After that, World Weather Attribution was launched to really dive into these events. Freddie already explained it nicely, and be able to crank the return time on turning an analysis on these events. Then the National Academies in the United States took a full assessment study in 2016. And this is critical because for those who follow the science, when the National Academies does a full assessment, they're looking at all the literature that's out there, and they really want to update where we are in the state of the science and where we should go going forward. And what they were able to assess is that before we couldn't attribute any individual event to climate change. Well, that narrative had changed. And now we know it is a part of the story. So let me take you through what we've been doing at Climate Central recently here with daily temperature and ocean temperature attribution, which I'll show you in a moment. But you already saw a nice curve from Freddie. We're getting sciencey here today. We're getting a little geeky, and I think everyone has understood curves a little more since COVID's happened, right? So that underneath the curve really represents all temperatures. And when you shift a little bit in our average temperature globally, look at how much more orange and red we get there. That means we've just completely changed our climate. And that's really the foundation, how we're able to assess the role of climate change within individual events. So nowadays, we're at about 1.2 to 1.3 degrees C of warming globally. With science, with our knowledge of individual weather events, and with our computing capacity and technology advancing, we can go in and take, as Freddie was saying, historical data and compare it with model data. And we can do is really tweak different atmospheric conditions. All those questions that she put out there that are being assessed scientifically, that's if we take it back in a world with lower amounts of carbon dioxide, closer to a 0 degrees C, or you could even crank it up. And when you assess that role, you can go in through statistics and probability and all of this modeling and take the role of climate change within individual events. And so for our climate shift index, where we're looking at daily temperatures around the world, and this is free and accessible on our website, and I'll give you the link as I go through this here too. But you can see if it falls within both of those curves, really no influence of climate change on that temperature. However, we're seeing so much more on that right-hand side right now. So we've been able to package this into an index. And the higher the numbers are on that index, the higher the influence of climate change on that event. Now, we do present it on the other side too. If temperatures are cooler than average or normal and can go through the full process too, they're less likely with climate change. And we're going to see them less often in the future as we continue to warm our planet. So this is really the snapshot of taking you through that bell curve. On the right-hand side, 1, 2, 3, 4, 5, more likely from climate change, less likely on the other side. And here's a snapshot just from today. I took this before we went on here. And if you go to our website, you can zoom in, you can get real specific data in any of these areas. And I already saw a question in the chat about the southwestern United States. It is burning right now. And I don't mean, well, so there are some wildfires, but I mean temperature-wise. We could hit 110 Fahrenheit in Phoenix, and it's October. This is not normal. And this is a way for you to bring this into your storytelling and build that confidence to say it is not normal. And so you can see this popping up on many different places on the globe, northern and southern hemisphere, even in areas heading in and out of winter here. But that's not just the air. We know that so much of the heat we're trapping in our global system is going into the oceans. And the oceans have a real long memory, right? So it takes longer to warm up and a lot longer to cool down. And over 90% of what we're bringing into our Earth system is going into the oceans. So we're seeing these numbers even that much higher in our ocean temperatures. And so here's a snapshot of today, well, from the Climate Shift Index Ocean, which we launched this summer, of where we're seeing these spikes in temperatures. But I have to really call attention to that yellow bar. We can get into this, into the conversation, where a lot of our data is processed. Now, again, it's stored in multiple locations, but the United States, the National Centers for Environmental Information, NCEI, is based in Asheville, North Carolina, which, as we all know, is underwater. And so they are closed right now because people are dealing with life-threatening situations. And we have not had some updates in the data since the storm made landfall here. But you still see there's a lot of red on this map. And these are on the order of 100 to multiple 100 times more likely because of climate change, that extra heat that's being stored in our oceans. We were able to do an alert on this before Helene made landfall. Actually, before Helene even became a hurricane, we were looking at the temperatures in the Gulf of Mexico, and you see 300 to 500 times more likely all of that heat that we saw stored in the Gulf. And that's what gave way to helped with the rapid intensification that we saw with Helene, and then all of the inland flooding that we saw, which we'll take you through a little bit here too. And I wanted to do this quick summary too, sort of where we are on a few different things. If nothing else, this is really building confidence to make the climate connection for journalists. And there's a couple of stories of journalists we've worked with. Even if you don't get into specific numbers all of the time, if you just go check this, if you're wondering, hey, is this normal? You can go check these indices and you can see, no, this is not normal. So you can really build that confidence scientifically to bring climate into that story. Also, this is being applied to impacts in so many ways, as Freddie started to get into, and we can get into discussion here. But when we have that quantification of a storm, it can get applied to economics, health metrics, a lot of things. We're looking even at power outages in different ways. So the real world impacts that people are experiencing, that quantified number can help apply to that. It's also used in rebuilding and thinking about how normal is this? What do we need to prepare for the future? And it's being incorporated in a lot of litigation and even loss and damage conversations. So looking ahead, the National Academies just formed their team, and they're about to go through another assessment study because this science is advancing so rapidly. And again, on the science side, it's really fun. And so they're going through that process right now. They're launching it this month. And now that takes a while to review all of the literature, come back with their assessment on that, just seeing how far it's advancing and how that applies to a lot of communication. So stay tuned for that in the future. Also, we continue to apply this to new forms of weather and science, from hurricane strength, fires, humid heat. This is on the research side of what we're looking at. We'll continue to build that into communication tools and packages and reports and alerts to help you be able to communicate that and bring that into your work. And oops, there we go. And then here's the QR code I want to leave you with to sign up for Climate Matters. And it's through our Climate Matters that you'll also get all of these attribution reports and heat alerts that we get as we move through the season here too. And those are the links for our CSI Ocean, and just our whole host of resources that we have on our site. So thank you.
Thanks so much. That's Bernadette Woods-Placky from Climate Central, and I urge all of you to be signing up for that. Likewise, Dr. Friederike Otto of World Weather Attribution Group, please sign up for all of their materials. It will make you a better climate reporter. And we here at Covering Climate Now, of course, also have a lot of resources that you can use to reiterate what Bernadette said, to build your climate confidence, to be able to say, to look into this camera and tell your audience that, yes, this is not normal what's going on, and this is why it's happening to you. That's our duty as journalists. You know, we oftentimes say at Covering Climate Now that we are paid by our employers, often not very well, but we're paid by our employers, but we work for the public. We work for the public, and it's our job to let the public know why what they're going through is actually happening and what they can do about it. So I want to thank both of our panelists for being very concise here. We've got a lot of time for questions. We've got some great questions already coming. Let me just remind my colleagues, these questions are for working journalists only. When you send your question in, please give us your name and your news outlet so that we can get to them. I'll get through as many as possible. I'm going to take the prerogative of the chair here first, just to clarify one thing and ask, Dr. Otto, you said that we're now at 1.3 degrees above pre-industrial level. Bernadette, I think you said 1.2. Which is the number that we as journalists should be using now, and why? Dr. Otto, you first.
That is actually a not so easy question, because of course, the global mean temperature are at the moment even much closer to 1.5 degrees, but we use the attributable temperature over not just 1 year, but a longer time frame, so around 5 to 10 years. So centered around this year, and that at the moment is, I think Bernadette's slides showed, at 1.27. So until the middle of this year, we used 1.2, and then we have decided to round it up to 1.3. And there's actually now an annual publication of a peer-reviewed paper on climate impacts that's currently led by Piers Foster, and they, for example, calculate this number, and we have decided to just go with the number they use, and they use 1.3, which is why we have chosen 1.3. So every year when this publication comes, we will see what the attributable number over this average time frame of around 5 years is.
Thank you. That's very helpful. Bernadette, do you want to add anything to that, or should we go right into questions?
We can go into questions. She said it beautifully.
Basically, folks, we round up from 1.27 to 1.3 for
It
those of
keeps
you.
going up, sadly. That's the biggest story.
Going up, and remember, 1.5 is the target. So let's see. There's so many good questions here, and I'll try to go through them quickly. Let me start with one, again, from one of our close colleagues at WBUR Public Radio in Boston, Barbara Moran. Hi, Barb. Nice to hear from you. She asked, what changed that allowed scientists to attribute extreme weather events to climate change? For a long time, it wasn't possible, but now it is. Is it an increase in computing power, an increase in the climate signal, or something else? So kind of kind of a science nerd question. Who wants to take that?
A bit of both, plus also that just really the development of the methodology. As is always the case with science, you always have to first come up with an idea of how you can do something before you can actually apply it. So it's really a combination of three things that the climate signal is much stronger now than it was 10 years ago, and definitely than it was 20 years ago. So we see just a lot more changes when we apply this methodology that had not emerged a while ago. And we have now more computing power, but it's actually not so much the computing power, but until maybe 5 to 7 years ago, it was really difficult to get hold of climate models for individual scientists. But since then, now all the modeling centers in the world share their data globally. And so every climate scientist in the world can basically use every climate model that is out there. And that allows us to access a huge pool of model data that we need for these studies that was just not possible before. So that's these three components, really. The computing power obviously means that all these modeling centers can now have this model data, but that's really a small role.
Fascinating. Let's go to a question from Arizona. Our colleague Tim Steller, he's the Metro columnist at the newspaper in Tucson, the Arizona Daily Star. He asks, leaving aside the hurricane for a moment, would you please talk about the extreme record-breaking persistent heat in the US Southwest and how you would go about attributing that, not just as scientists, I'm going to add on here, not just as scientists, but how, as a journalist in that locality, how can journalists there talk about that? Bernadette, how about you for that one?
Absolutely. So Tim, I think you got a little snapshot of that. Sadly, this is so persistent, and we've seen that red blob over your area for months now. So you can go each and every day and you can take a look. And if you need that confidence, or if you need a connection, or if you need a specific number, it is there for you, sadly, every day, pretty much. For the duration, that's a different thing. We do have a hindcast, so we could even work with people if you're interested too, of looking back over a full season and getting some more information on that. Now, we did just do a seasonal analysis for summer, which we define as June, July, August. Now, I know yours has extended outside of that. But in that seasonal report, there are a lot of numbers for Arizona and for your specific city too, in Tucson and in Phoenix. And then we can add on some of those additional months if you wanted to do a deeper dive into that, because we do have a lot of additional data, because it is so extraordinary, not just the numbers, how high they are, but how long that's happening. And we can work with you to try and pull some of those numbers.
Thanks, Bernadette. Here's a really practical question from our colleague at Inside Climate News, Bing Lin, who says, I'd love your take as scientists on the language you'd like to see us as journalists use when we're covering these types of results. Causal language versus correlative language is really important to get right when conveying science. And I'd love to know which bin these results fall under. So basically, you as scientists, what should we as journalists be saying about this? How do we say it so that we're accurate? But bear in mind, of course, that we are talking in the vernacular. We're talking to the mass audience, many of whom do not have scientific degrees. So I'd like to hear really from both of you on this. So Dr. Otto, could you please start?
So I think it is actually really important to use causal language and not correlation, because we do know that we see this increase in heat waves and this increase in flooding and heavy rainfall is caused by human-induced climate change, and actually and it's not just a correlation, because a correlation could also just be by chance, but this is really not chance. But we know this is happening and why this is happening. So I think it's really important to use causal language. And of course, it's not a caused by climate change in a yes or no question. It's not like, okay, without climate change, we wouldn't have hurricanes. That of course is not the case. But it's the same thing in the same kind of causation that we use when we talk about smoking, or that, yeah, you would still have lung cancer in the world if people wouldn't smoke. But if you do smoke, you have a much, much higher likelihood. And so there is a causal relationship between that and lung cancer. And that's the same kind of causation that we do use in everyday vernacular language. That is appropriate here.
Bernadette?
And building on that, there are a lot of cool numbers in the science here, and you're spending the time to get educated on that. I think it depends on how you're presenting that, right? Don't overly focus sometimes on the numbers. I think it's good to add that confidence in a statement that you're putting out. But the biggest point is what Freddie just said with the causal and making that connection. Sometimes if you're getting too caught in trying to put too many numbers out there, it's really climate change, climate connected, climate cause, whatever it may be, but making that connection for the general public. Because what we see so much in the social science is that people know something's happening, but they still genuinely have questions on what and how that's affecting them. There really is a gap on that. And so this gives them, this is helping to serve your audience and answer their questions. So the causal piece, yes. And just don't overly complicate the numbers.
I'll add in here too, from Covering Climate Now, we find that, again, you can say this in one sentence. Maybe the easiest way to, what does causal language mean in a vernacular sense? Here's an example. Such and such storm was made twice as likely by climate change. That took me about 3 seconds to say, right? Twice as likely. That is something the average person can easily understand. 3 times more likely. We easily understand that kind of thing. So there's a couple of tips for you. Let's continue on here with a question from our colleague Bill Kearney at the South Florida Sun Sentinel. Is there a way to measure the volume of rain a hurricane produces and compare that to hurricanes over the past 20 to 50 years, et cetera? Does that data exist? And can we say, for example, hurricanes in the 21st century on average produced more rain and thus flooding than those in the 20th century? Who wants to take that one?
Go for it. That's what we were just talking about this morning. I'll say one general thing and then hand it to Freddie. The biggest thing with attribution science, and I want to be clear with everyone here, is we're really focusing on attribution science. That's the point of this. It doesn't mean there aren't connections that you can make to climate change in general that we know about weather trends. So I don't want people to get so caught that they have to wait for an attribution study to make those connections. Like, let's be very clear about that. There's a lot we know in the science. But when we focus on the attribution science, what's really fun and how to come up with the numbers is defining the event. You heard Freddie say, you know, the event definition. It's in space and time. So how many days of rainfall are we looking at so that you can compare those numbers to historical numbers and model numbers? Also, what space, what geography, how many, for example, Helene, we're talking this morning, how many states to include, what geography for that event definition. So that's how we approach it more broadly. And then Freddie, you can get into the more seasonal stuff.
Yeah, but I mean, to build on what Bernadette just said, so when we have defined the event and say we are looking at the 2-day extreme rainfall over the states of Florida, Georgia, and look at the hurricane season, so say just the summer and up to November, and then we can say, okay, and the event that we are interested in is today is a 1 in 100 year event, and that has, I don't know, 700 milliliters of rain, or I make this number up now. But then we can say, has this number changed in a world without climate change, or in a world that at the beginning of this century? So, and that is, and we see for actually rainfall associated with hurricanes in the US, we see, yes, the 1 in 100 year event would have had less rainfall. So if you build your infrastructure to withstand the 1 in 100 year event, then actually what is now a 1 in 100 year event is not, it has more rain than it used to have at the beginning of this century or at the beginning of the Industrial Revolution. And so your infrastructure is actually not fit for purpose anymore if it was built to withstand that. And so that's how we can track over time how, as you said, the volume of rain associated with a particular type of hurricane or with a particular type of impactful event has changed.
And that happens to be a perfect lead into the next question, which is really quite interesting and cutting edge, from Patrick Eichelmeier. He's the science editor at Tagesspiegel, a newspaper, I believe, maybe a news magazine in Berlin. His question, looking at the development of attribution research, will you be able to arrive at estimates of the costs, the economic costs of climate change? 1 more tenth of a degree will likely result in economic losses of what? Or is that level of knowledge still out of reach?
There are already economic assessments going on through attribution science. We at Climate Central had done one on Superstorm Sandy making landfall and how much more money that costs. Because once you go in and you get that quantification of an event, you can then apply it to the economic numbers that exist or the health numbers that exist or many different things that have data sets. You can do that application.
Yes, it is not done very frequently yet. And I think there are different methods to do it. But while actually the attribution science of the weather event is now very standard and has been assessed in IPCC reports, in the National Academy of Science report, as Bernadette said, and many times, there's not one way of how you can apply this to the economic numbers. And there's also a huge uncertainty in the economic numbers itself. So it's a different kind of science that you go into, but it is definitely possible, and it's definitely possible to use attribution science also to at least have an order of magnitude of how much it has cost, even if it's hard to say the exact dollar numbers.
Thanks. I'm going to give a little peek behind the curtain here at Covering Climate Now. We will be talking in our Climate Beat newsletter this Thursday about this very question under the headline, Who Pays for Helene? Right now, it's basically taxpayers who pay for the costs, the Federal Emergency Management Administration, et cetera, all the costs of the emergency equipment, the rebuilding of the infrastructure. Those are taxpayer costs for the most part, a little bit to insurance companies. However, there are new bills in Congress and New York State that may change that. Those are bills called Make Polluters Pay. And they are moving through Congress and New York State. The state of Vermont has already passed such a bill. And that's an interesting new angle for reporters to explore as we go forward, again, based on this really terrific work on the attribution part. I'm going to go now to a question from
We'll give him a minute. If not, we'll jump in.
I mean, you can pick a question, Bernadette.
All right, let's do that. We'll just start jumping in. Seriously, so many great questions. One that stood out to me, Lauren Watson here from Columbia Journalism Review, talking about local journalists in the middle of a crisis. Are they more focused on the issues in front of them, shelter, food, access? What types of tactic support exists for them to weave causes and correlations into their work when they're in the moment of this community? I'll give a sense, and you can jump in too, Freddie. This area we work a lot is with local journalists. This is now part of the story. Climate change is part of the weather situation that's going on. And as I brought up earlier on, as we talk about rebuilding almost right away in many of these communities, we need to know what we're rebuilding for, what is coming our way. And without the knowledge of even updating systems to today, let alone the future we're headed toward with continued warming, it needs to be part of the conversation in keeping people safe and prepared. And so that's where I see this. Now, of course, if there are immediate warnings that exist, with a flood warning, with an evacuation warning, that doesn't mean climate is in every single broadcast or every single statement, but it is still part of the story.
So I saw a question from Jean Soublet from Inside Climate News that I thought was a good question, because Mike Wiener from Lawrence Berkeley published an attribution on the rainfall associated with Helene earlier, I think, my today, but I think it was your last night in the US. And the question is, are these numbers believable or should we wait? So I think there are, of course, different ways of how you can do an attribution study. And what we do at Weather Attribution is that we could try and combine different methods and different models. So because if you use one data set or one model, you often learn more about the model than about the real world. But when you combine different data sets and different models, that gives you some confidence that actually what you find has something to do with the real world, and you have not just by chance found a model that said something for reasons that are not connected with climate change. And so, and the study that was put, the results from Mike Wiener, they are based on just observations and one method. But actually in this, and so if it would be about East Africa, I would say absolutely do not report it, because that's a part of the world where we have very few observations, where different data sets often give very different statements. But actually in the US, where we have very good observations and also a lot of climate models, and they all are very, so there's been a lot of work trying to get these models right. These numbers are actually probably pretty close to what we will find when we combine all the models and all the methods in our study. So I would not necessarily maybe say, okay, it's exactly 50%, but it gives you a good idea of the order of magnitude, I think, in this case.
And hi, Sean, for those who don't know, he used to work with us. And welcome back, Mark.
Thank you. I got kicked off, but I'm here again. I have a question as someone who's been on the climate beat for a long time as a reporter, to both of you as scientists. Do you notice any difference in how journalists and news organizations report on climate attribution from country to country? Is it different here in the United States as opposed to, say, Japan or Germany or India or Brazil? I mentioned in my introduction that it's been disappointing, frankly, that so few US outlets, with some noble exceptions, have mentioned the climate connection to Hurricane Helene. So I'm curious to ask both of you, do you see any kind of a difference? Because covering climate now, we have a lot of our colleagues are not in the United States. And curious to know how that looks from your perspective as the people providing this knowledge to us. Bernadette, and you want to start? And then
I can
Dr.
start,
Otto.
but Freddie has a much more international experience with this than myself. My experience is, I mean, the conversation is fundamentally different in different parts of the world, right? Even from the weather perspective, outside of attribution science itself, working with TV weather presenters around the world, a lot of countries didn't have the data to ground the conversation. We're almost over-attributing a lot of things to climate change. And there could be other on-the-ground features, whether it's how they're governing a community, how they've built communities, I mean, there's a lot of different things that come into play that can lead to a disaster, not just the weather event. And that gets into Freddie's vulnerability and exposure. And so it's important to bring out all the information so that we can make people safe and prepared in the future. Weather is a piece of it, but if it's also a governance or a data issue or something else too, that needs to be brought into the conversation. Now in the United States, we've got the data, we've got the information. It's a huge polarization and still this ridiculous need to try and prove that this exists. Whereas that conversation is so 1980s. And so it is a different conversation, but we have found a lot of people in the US have built confidence in their climate reporting through attribution science. It was that check that, yes, this is a climate connection, and I will make that connection in my story, whereas they wouldn't before. And a great example is working with the NBC team, Lester Holt and Catherine Prosif. There was an outbreak of a tornado event, and they were questioning, do we bring climate change into this or not? And she looked at the climate shift index and saw how crazy warm the atmosphere was that led to those off-season tornadoes, and was able to make that connection through the climate shift index to say, yes, look, check, climate connection. And they were able to go on with that story to make that climate connection. So that's where we've seen a difference in the US in climate reporting through attribution science.
So I think
Dr.
briefly, I think it is definitely quite different in different countries, how journalists report on it. But I think it also, one of the reasons is that it's different types of journalists. So for example, if you go to the Netherlands, you have extremely specialist environmental science reporters who get totally upset about the third decimal point in your numbers, maybe losing actually focus of what the main story is, that it's about people and affecting people. Whereas for many press briefings that we do in African countries, it's policy reporters or business reporters or just reporters from any beat that that report on these types of extreme events, because it has such a huge impact on the whole society. So and that then obviously you get very different questions from people who have never reported on science before, than when you talk to people who are trained scientists and have always just reported on science. And I think that's the biggest difference that you see between countries. And then of course, depending on where as Bernadette said, where the political debate is, whether climate change has been part of the culture wars, or whether climate change is actually seen as what it is, a threat to human rights for everyone. That of course then also shapes a lot of the questions and the reporting.
So I'm going to try, thank you for that. We are running out of time. I want to try and get in two more questions. So quick answers, please. First is from a colleague at the Deccan Herald in Bangalore, India, who says that the Indian Meteorological Department just said today that the monsoon this year was nearly normal. But the question that the reporter has is about the cumulative millimeters of rainfall. Does climate attribution science look into the changing precipitation patterns? For instance, a certain amount of rainfall falls within a day or two rather than a week. There's been a lot of confusion about that in India. Can one of you clear that up fairly quickly?
I'm going to tag Freddie on that one.
We can look at that, but it depends. It really depends on how you define the event. And we have actually seen that globally, that a lot more rain falls in a shorter time. So if you look at the whole monsoon, you don't see a change. But if you look at the one day, you do see a change. And ideally, we would look at both things in every study, but sometimes we only look at one of the two things. But that is definitely something where there's also a lot of literature that shows this. So that's something that, even without having an attribution study, is fairly safe and very clear to report that we have this increase in rainfall on the very short timescales.
Yes, and that intensification, those downpours, that's what leads to flooding that we're seeing, for example, now in the Carolinas. One last question from our close colleagues at AFP. This is from Benjamin Legendre, who says that AFP often relies on world weather attribution studies, and we find them trustworthy. But can we have the same degree of confidence in tools such as Klimameter, which rely on quote unquote studies established in less than 24 hours? What's the difference in quality and robustness between your studies and their studies? Again, Dr. Otto.
Klimameter is not actually doing attribution. Klimameter is only doing what we call detection. So they look at one data set, only observations, and basically count how many weather patterns we see in the last 20 years combined to how many weather patterns we see in the 20 years before that are similar to the event today. And that sometimes gives you an idea of the role of climate change, but sometimes it really doesn't, especially when the weather patterns you don't actually find similar weather patterns. So I think they are useful in connection with an attribution study, but not in itself.
Thanks so much. I think everyone who's attended this webinar will agree with me now what I said at the top. We really had two of the world's top experts on this. I think they have armed all of us as journalists with the power that knowledge gives, as the old saying goes, the power that knowledge gives. And it's our job as journalists to use that power and give that same knowledge to our audiences, to our listeners, to our readers, to our viewers. Please come back to all of the resources that are available from the World Weather Attribution Group, from Climate Central, and of course also us at Covering Climate Now. I want to close with a very warm thank you and expression of gratitude to both of our panelists today, Bernadette Woods-Placky from Climate Central, Dr. Friederike Otto from the World Weather Attribution Group. And on behalf of everyone at Covering Climate Now, I'm Mark Hertsgaard, wishing you a very pleasant day.